Hi, this is John Weber with Schneider Electric. Thank you for coming to the webinar. We're going to be talking about containerized off-grid system solutions. Probably the most important things we're going to be talking about through this presentation is exactly what a containerized solution is. Of course, why it has a value compared to maybe a stick-built or brick-built solution or even using an existing structure. Where you can put this solution, be it from a military application to just remote power for indigenous people. Also be talking about some of the things that we have to take into account when we're designing a solution like this, be it making sure that we understand both winter and summer temperatures because of energy storage and inverter surge needs, as well as just what we're going to be using the system for if it's going to be near a dusty road or whatnot. Finally, we'll be getting into exactly why the inverters from Schneider Electric, the XW Plus, is such a great fit for those three-phase applications in particular, but we also do single-phase 230 and single-phase 120/240. Schneider Electric does want to support you guys on being able to do these solutions. So setting up and going through our website to look at the design resources that we have available, be it CAD skins, or if you need some heat profiles, we can provide those as well. Some of the things that we've done in the past are going to be highlighted in our case studies, as well as some of our partners who have already done some of these things in the past. We'll be talking about some of their successes as well. So let's go ahead and start talking about Schneider Electric does take your safety very, very seriously. Please remember that only qualified electrical personnel should gain access to the equipment, and make sure that all power is turned off and disconnected before doing any visual inspection, testing, maintenance, or installation of the electrical equipment. Failure to do so can result in those serious injuries, property damage, or even possibly death. As well as the inverters and electronic equipment can get quite warm, so please be cautious when around it. Even if it's turned off, some of that equipment can remain quite warm for quite a while. Exactly what a containerized solution is. So when we talk about containerized solution, oftentimes it's going to be something that we're going to find inside of, well, a container. But it doesn't have to be. This can be a pre-tested solution that is put into a trailer solution. And so really the most important part of this is understanding that it is the everything in one box. So we're going to have monitoring with the XW Pluses. Of course, we have the opportunity for dual AC inputs. We have AC output breakers that can be either provided inside the unit or just out to a distribution panel for that commercial/industrial load. PV can be mounted directly right to the box, or it can be set so that that system is a ground mount away from it. Of course, we're going to have all of our storage, charge controllers, and everything else. One thing about containerized solution, of course, is the modularity of it. And we'll get into a little bit more of it talking about modularity. But remember, especially with higher temperature areas, instead of putting an AC unit to try to cool inverters and batteries, it may make sense to actually break that system apart into, say, two 10-foot containers, or isolate the energy storage on one side of a container while putting the inverters and electronics on the other side. May save you some energy costs when we talk about using AC power. So let's look at the value proposition for this system. The thing to note about this slide is that within containerized systems, it offers a lot of things that have already been tried and true throughout various industries, be it data centers, substations, or even desalination. These are three prime examples of how a system can be deployed rapidly, knowing that the system's going to be worked because it's already been pre-tested before it even gets out there and gets put onto the site. Of course, being able to increase the size of the system by just simply adding more building blocks is something that is fairly unique to the Schneider Electric XW Plus, but you can see here that it creates that kind of repeatable solution, so we can see that system working over and over again. Perhaps the number one question that comes up when talking about containerized solution is that upfront cost that comes when bidding compared to basically doing an on-site off-grid system, either using an existing structure or building a structure on site. There's a lot of benefits that come with doing a containerized solution compared to something on site. For example, and we show here in the slides, going out to the site, doing a site audit of a physical install. So for the example, we're talking about a building that already has infrastructure there and you're adding more infrastructure to it. Customizing the equipment for the layout of that site adds a lot of time and cost and trips out there. Whereas when we have a containerized solution, we're looking at a repeatable solution that can be deployed at one site or multiple sites. As well, when we talk about logistics and efforts, we're talking about getting from point A to point B. There can be customs issues with getting things across the border. Why do that more than one time, especially if we have several boxes coming from various sources, whereas with a containerized solution, it's just one box, so it keeps everything nicely together. Of course, when we're looking at on-site off-grid systems compared to containerized off-grid systems for civil works, talking about getting that site ready for building for install. It could be that because we're adding infrastructure to an existing building that we're going to have to bring other parts of that building up to code, as well as just getting access to different parts, especially if you have people that are living there currently. When we talk about the containerized solution for civil works, getting that system in there, dropping it on site can be very, very minimal, just simply because it could be something as simple as putting down a gravel bed, or we'll show later on in one of our slides, putting in actually just little concrete footers that hold then the container up. Of course, once we're on site, and this really is the most important part of it, is that just the amount of time that's spent on site, if we're bringing in individual pieces that have to be individually mounted, just the logistics of bringing in that amount of skilled labor into an install can become very, very time consuming, and time consuming equals soft costs. We talk about containerized solutions. Of course, this is a solution that's already been built, ready to go in, and really makes for the fastest install. We showed in that previous slide that a lot of other companies, a lot of other solutions are already using containerized solutions because you can get people in and out very, very quickly in just a couple of days, compared to an on-site off-grid system. People could be there for weeks, and depending on the location, it's also going to make it a difficult proposition to keep everybody housed there, and so costs start to rise on that side. Of course, everything getting installed, even the best installers out there can sometimes have a whoops moment. It could be a broken breaker, or it could be that it just gets wired incorrectly. When we work with a containerized solution, we're doing that in a controlled environment where we have access to resources, and then we're moving that container to the final site. So we know that that container is ready to go. It is cookie cutter and repeatable, meaning that we're able to put that system in one go and can scale that system up. And again, I can't say this enough, when we look at the XW Plus and what we're comparing to with scalability on other solutions out there, typically we will have one battery bank and that's all you're stuck with. With containerized solutions, with the Conext XW Plus, we're able to actually bring in new battery banks and actually grow the system and scale it up over time. So when we get to the value proposition and talking about engineered solutions, what we're really talking about here is, how we can make that system as perfect as possible, and doing that in a manufacturing facility where we have absolute control over that system is exactly what we need. And so engineering, running those conductors exactly how you'd like it done, you have that versatility, so you can have that flexibility to mount and run the wires. You don't have to worry about missing components because you're going to be doing it in a place where you can always have access, because this is probably a repeatable solution where you're going to be doing it. We can ensure really top quality workmanship, because we're going to be testing the system as we go. We're able to test the system once it's done, so that when we drop it into site, it's ready. Of course, if we're in a very, very remote location, connectivity can be an issue. So, Schneider Electric is always working on improving its firmware, which means that we always recommend doing firmware upgrades. So if you're out in the field and you're missing that driver and you don't have internet connection, there's another reason for another trip back to the site, which can be very frustrating. Containerized Solutions help get rid of that because we've already got the software loaded, because it is that pre-tested solution, and we can run through all the different operating modes. We can validate that all the protections and everything else is already right there. So when we talk about that value proposition with easy logistics, how do you get that system to the site? How do you make sure that we're going to get it to exactly where we need it? And so, 90% of all remote sites can be delivered by land, sea, and air. There are those unique sites where containerized solutions may not make sense, but for 90% of the systems out there, doing something in a container, bringing it to site makes a ton of sense. Planning the location and doing site delivery beforehand is something that's very, very important. So when we talk about doing that site survey, we're not just talking about putting that system on the ground with those concrete footers or a gravel pad. We're also talking about the logistics of getting it up the mountain, down the road, down a dirt road, fording a river, if you will, to get this system installed. And so all of these things need to be taken into account when we are transporting this. Of course, we'll look at what the weight of batteries adds to these solutions, but it could be up to 40,000 pounds worth of batteries into some of these solutions. So much, much easier to make sure that we understand exactly how that site's going to go there. And because of the modularity of this system, we're actually able to bring the electronic components and possibly the storage components in two different systems. And what I mean by that is that if we have some bridges or we have some bits of land that we're going to be transporting this equipment over, and the weight could become a factor for getting it there, knowing that we're going to get it there. Logistically speaking, because of the modularity of these solutions, and we'll show you in a little while, you can actually break out the energy storage into a separate container than the electronics. There's a couple benefits to that, but in the case of getting it there and getting it installed, it allows us to divide that weight out a little bit more evenly. One of the other nice things with using a containerized solution, what eases the logistics is that we can actually use that container to mount the PV or at least transport the PV modules inside. Again, keeping things safe for security one time through that border check, and then being able to use that structure as part of the PV mount can have a great deal of benefit. As well, you need a lot of tools that you're going to bring along to the site. So being able to package those up inside the container just, again, eases the install and makes sure that nothing gets forgotten or left behind because you've done your double checks already at the manufacturing site. And then when you move it to the install site, you have everything right there on the box. Talk about just that scalable solution when we look at the system overall. So when we're talking about scaling this up, we're talking about the actual containers. In speaking with our partners, a lot of them did start out with that 10-foot container just simply because it allowed them a smaller footprint, and as well, for the most part, they didn't need that much space because of the sizes of systems that they're working with. What they learned over time was that actually the 20-foot container ended up being the most ideal container. It gave them room to not only put the energy storage and electronics in there, but also gave them extra room to hold PV panels or actually use the whole container. And we'll show a case study here in a little while of what a 40-foot container can be used for, but above and beyond just the solar side of things. The other really nice thing, again, is that scalability we've talked about again and again. But here on the right, we can see that we have the cub. And with the cub, we can actually integrate and build up that system over time. So we can just continuously add that modularity to the system and keep building it up. There really are a lot of neat applications that we can bring to containerized solutions, especially when we start looking at being able to do sort of rapid deployment, if that be for disaster recovery or, say, mobile command centers and communications where you need to get something there very, very quickly. It can also include for disaster sites something like clean water and purification so that you have a centralized area that people come. Some of the other neat applications we've seen with containerized solutions is bringing that kind of trailered medical clinic to the location, which means that medical treatment isn't dependent on any external sources of power. That if there's specialized medical equipment inside a vehicle and you're depending on an external grid or generator to work, kind of letting Murphy's Law, and if you will, what can happen will happen, and that can run things afoul when it comes to bringing good quality medical treatment. And then you don't have to worry about permitting to run power. There are some, if you think about the size of a solution that's 70, 80 kW of a solution, suddenly you got to start thinking about if there's going to be special permitting to make those interconnections. For military and tactical situations, there's a lot of neat applications where being able to rapidly deploy energy, where you're able to do fuel savings using a generator and a modicum of solar power can make a lot of sense, just simply because delivery costs to remote military sites and reducing risk to delivery of that fuel to those sites are all things that are being considered by battle commanders. And so being able to rapidly deploy a system that reduces its fuel consumption and can use solar at the same time is a fantastic idea. There with the solar rover down in the bottom right corner, we can see where we're using the system basically as a music festival or athletics events mobile power solution. So this allows you to run instruments, some lighting, amplifiers, and things like that. Can reduce the overall costs that come with just running a generator 24/7 to being able to have the exact right amount of power at the exact right time, which is what energy storage and inverters really allow you to do. It just opens up those possibilities for a lot of different applications. Construction sites is one project that I've worked with a company on, and essentially, there's limitations on how long they can run their compressors and things like that in a community while building another home. And so if you already have people on site, you can use solar along with generators to keep that system going so that you're not running those generators past curfew, but then you're able to continue doing some sort of construction there on site. So really think about some of those options and those opportunities that come with containerized solutions. We'll go ahead and dive into a few applications that really stretch into kind of cultural and continental issues. We talk about providing power. This was a slide that kind of hit home just about the amount of required power that's needed. We'll spend the next few slides just talking about where power is needed and kind of some of the whys of where the installs can go. So in 2012, nearly 25% of the population of all developing countries had no electricity. So that's a huge number. Latin America, surprisingly smaller number than I expected, but then in sub-Saharan Africa, we're looking at almost 57%. We'll go into a few reasons within Africa itself about why this makes sense on a large scale to bring in this power, how it can help benefit the lives of people around us. When we look at places like Canada, we're talking about places where we have indigenous communities as well as, say, mining communities or research communities that are very much dependent on diesel. And so one of the nice things when we're using storage and solar, even in these northern latitudes, and being able to bring a solution in like this is we're able to reduce the dependency on fuel, and it can become quite expensive to actually deliver that fuel. Average unsubsidized cost is 40 cents a kilowatt hour. For some communities, it can be as high as 80 cents a kilowatt hour, whereas subsidized by the government, it's down to 28 cents per kilowatt hour. So there's a lot of communities out there very dependent again on that fuel consumption. Anything that we can do to help reduce that is definitely going to help in the long run. When we look at containerized solutions in those northern latitudes, of course, we're talking about leveraging the energy storage as well as leveraging solar. So don't think that because we get into the 60th parallel that that is not a place where solar is going to work. We can do this with insolation periods in northern latitudes, and using a tracker, we get 8 hours of sunlight. Of course, in the winter, we're going to get 0. So, using a generator does absolutely remain key, especially if we have variable loads, which means that, especially something like at night, the community expects that the lights are going to stay on. Using storage on site along with PV can allow that generator to turn off during very low times. And then once the loads come up, of course, then we can start using that generator again. So just depending on the size of the PV, whether or not we're going to be using trackers, all this stuff comes together to making a containerized solution that's pre-built, pre-tested, and ready to go on site make a lot of sense in the long run. When we look at Africa in general, again, the Sub-Sahara has a huge need for power. And a few statistics around this shows that about 2/3 of the population is more than 2 kilometers from a year-round access to roads. So we're really talking about quality of power, and not only that, but interruptions. So if we're seeing a lot of brownouts, that can be very hard on more modern equipment that's being installed. And when we're talking about interruptions, we're just simply talking about straight power outages. So low quality power, of course, is going to discourage economic investment for these communities. Being able to guarantee that we have power 24/7 can make a lot of sense for these communities. And the global community is expecting that if they want to bring in industry or manufacturing to these sites, you may have willing labor, but if you have an unwilling grid or the inability to produce power, then we're going to run into issues as well. Power services to communities benefit really from reliable power. When we did that survey of sub-Saharan African communities, when there was a survey of sub-Saharan African countries, the question was, what do you think are improvements achieved so far in your community with regards to social and economic well-being? And really the top things: schools, farming, hospitals, infrastructure, electricity, water, business, and information access all definitely benefit from having reliable power there. All of these improvements really do mean not only just access to power, but access to actually very, very high quality power. So we've talked a little bit about those northern latitudes. One of the things that we need to keep in mind, and we'll have a case study on this in a little while, is that we don't actually have to have solar to have a containerized solution using the Schneider Electric Conext XW Plus. But we can leverage using the power that's already on site with a generator with storage. Hopefully being able to get that generator turned off. Using load support feature, we can actually inject current when the generator needs it. So if the site's starting to get too large, for whatever reason, solar doesn't make sense, we can charge those batteries when the loads are lower and keep that generator at a very, very narrow profile of peak efficiency, and really be able to leverage the energy that we're creating on site in the best way possible. Of course, the other thing to consider is that we spent a lot of time talking about renewable sources with PV, but we can't forget that we also have access to wind as well as hydro. One final thought on this, in this diagram that we have here, we show both grid power as well as diesel. One thing to consider, especially if the quality of AC source is very, very poor, what you can do is bring in inexpensive 100 amp DC chargers that are rated at 48 volts, which will literally just buy that dirty brownout power, if you will, and be able to charge those batteries. From there, the Schneider Electric XW Plus is going to be able to provide very, very clean AC power. So if you're in an area where the grid is there, it's there most of the time, but the quality is so poor that you're running into damage to electronics with peaks and valleys that are affecting everything. then this is a great way to leverage just using the XW pluses along with storage in a container solution, and just simply using DC chargers to buy power from that dirty source, put it onto the batteries, that kind of like a giant sponge, and then provide very, very clean power to that source. So what are some of the design considerations that we should take into containerized solutions? Let's talk a little bit more about exactly what it's going to take to put together a containerized solution. The benefits when we talk about containerized solutions and exactly what they're capable of doing, we're deploying your own pre-built structure. And of course, each site is absolutely unique. So if it's a new site where there's no structures built whatsoever, or if it's retrofit, we really have to think about what the impact is going to be to those structures, how much time we're going to be spent waiting for our turn to get the electronics and storage installed, or can we bring in a containerized solution once all the structures are there? And so the impact to an existing structure is definitely kept to a minimum, since we're running a small trough essentially from the containerized solution into the AC to distribution panel. May require an update to the distribution panel so that if we want that modularity for growing into the future, that we definitely have it. Some of the other things that we of course have to consider is those highs and lows temperatures. We'll talk a bit about this throughout the rest of the presentation, but understanding whether or not we're going to need active or passive cooling. Active cooling can be using an air conditioner or actually just pulling air in an active way through the container. Of course, if we're working with flooded batteries, we're going to need that anyway. Passive cooling can be done when we're talking about putting the container into a shaded area, or actually using the PV array itself as a shade device for the unit. Of course, once we're on site, we need to think about exactly what sort of environment it's going to be in. Is it going to be in a big paved area or a grassy area, or are we going to be putting it next to a very dusty road? And so making sure that we put in the right ventilation and control the amount of particulates, or keep all particulates out, is another great thing about containerized solutions. We can see here that a couple different ways of drawing air in and pulling it out. This is a filtration system, really HEPA filters, keeping out particles so that we have absolute control over the environment that our batteries as well as our electronics. You can see there on the slide on the right hand side that those walls look a little bit thicker than your normal what you'd find inside of a container, and all that is about reducing the amount of heat load inside the system. Of course, once we're on site and the system's being installed, the really nice thing with this is that because it's a steel container, much harder to get into, we have security, and we can reduce the general access to the system. If it's just a door inside of a structure, people feel like I should be able to go through that door. Whereas if it's a containerized solution with a big padlock on it and very, very secure, that's going to limit the number of people that are going to have access to it, and we'll be able to reduce the number of button pushers that are out there. One thing to consider when we're putting that container on site is that we don't necessarily have to pour a foundation, really depending on where it's going to go. In this example, we see here that just some simple concrete footers into the 4 points was added, as well as a treatment to the ground underneath it to keep the weeds under control. So there's a lot of really interesting things that we can do with a containerized solution to keep everything under control and not have to worry about having this system be built around a structure. So if you decide that you want to design your own system within a containerized solution, there's some things that we should consider while getting that system ready to go. Of course, if you decide to do something like load things up onto the walls, we have to take the load rating of those walls into account. You can see here on the photo on the right-hand side that they've got a little crane. My venture to guess would be to actually help deliver batteries inside of that system. One of the things that I like that I've seen done is where they actually build an internal prefabricated structure that allows them to run all of the wiring and conduit inside, and then mount the inverters so that we take that load off the walls as well as the total load rating of the entire container needs to be taken into account. We've talked about that a little bit when we've talked about how to get something to a site. Maximum load weight for each individual container varies per length. Of course, the longer the length of the container, the more weight that they're rated for. But when we're talking about energy storage, we're talking about a lot of weight when we talk about lead acid batteries. Per pound, we're talking about 20 watt hours. So usable would be 10 watt hours. Or even less than that. That's one benefit of going with lithium ion, which the Schneider Electric XW Plus, of course, is compatible with, is the lithium ion solution. So if weight becomes a huge consideration based on the size of the container chosen, you may want to look at using lithium ion for that solution. Of course, what a lot of our integrators are using right now is they're actually not using the containers that you find down in the container yard next to a port, but they're actually working with container manufacturers to custom build a container to their specifications. And this can include making sure that the load wall rating is up to spec, as well as making sure that they have room for bringing in insulation and things like that. Of course, when working with a manufacturer, these are all ISO manufacturers, and so they'll be able to build a repeatable solution over and over again. And again, this gets into that modularity idea that's so important when designing and considering using containerized solution, is making sure that we actually have a consistent product across the board. So let's go ahead and look at and talk about the Conext XW Plus. In particular, with the three-phase solutions, we kind of have two different styles that fall under one word. So we have the multi-unit solution, and under that we have the multi-cluster solution. Both are three-phase. The difference between the two, of course, is that the multi-unit solution allows energy to pass through. The one limitation is that 36 kVA, whereas with the multi-cluster, we're using an external contactor, so we're not having to be limited, if you will, on the pass-through current of the internal contactors. So we use an external contactor, and the inverters provide an AC sine wave on their AC input. They will also inject current on an existing AC sine wave as well. So if a generator is running or there's an AC signal there, a multi-cluster can sell power or push current onto that solution. So with the multi-unit solution, again, we're talking about a maximum of 6 XW pluses. Something to consider when we're talking about, again, this modularity of the system is having a single stack of three-phase XW pluses, energy storage. And the really nice thing about the XW Plus, mentioned it before, is that we're able to bring in another 3-stack, configure them so that they're communicating and sharing power to the same AC panel, and they can actually bring in a second battery bank. So if we have one that's a couple years old, the battery bank was 1,000 amp hours, let's say, and we bring in a second inverter, we can bring in something very similar, 1,200 amp hours, 1,000 amp hours. Traditional thinking says, hey, you can't mix old batteries with new. It's a big no-no. But because the units are using a battery management system that's individual to each set of 3, they can actually use that energy storage in an appropriate way and balance the loads so that the system with the larger capacity batteries are going to be working a little bit harder, but we're going to balance within about 5% those inverters and that battery bank between them. For the multi-cluster, again, the thing to note is that because it's on the external conductor and we're pushing power on an AC input line, the inverters can't do things like gen or load support. So there are some limitations to understand when it comes to that. We have a great white paper on the multi-cluster solution that really divides this stuff out. Head to solar.schneider-electric.com. Check out that white paper that you can find under the XW, and it'll give you some more information. So for design considerations with thermal planning, we need to make sure that we understand that we have a box that's going to hold some of that heat in. And we really want to try to keep that container at an ideal number, somewhere between 25 and 30 degrees Celsius. This is particularly important for lead-based technologies, but also is important for making sure that the inverters have the capacity to cool themselves off, especially after they've done a surge. If we're running at the rating of, let's say, 40 degrees C, that's the maximum that the inverter can run at nominal. So any surges that we ask the inverter to do can put us into a risk of thermally overloading that system, which it's then going to self-protect. So for heat sources, power conversion is going to result in heat. And basically we can take the efficiency of the inverter and convert the rest of that into heat. So if we're looking at a 5% loss, so a 95% efficient inverter, 6,800 watts, we're looking at about a 340 watt per inverter conversion rate. Same thing goes true for if we have a 4 kW solar array and it's 98% efficient. That 2% is going to add up. So we need to add up all of these different numbers together to really understand how much power is going to be produced across the line. When looking at the balance of systems, of course, we have conductors and everything else. That too is going to be creating a little bit of heat. And this stuff all adds up, especially not in an hour or not 24 hours, but day after day in a efficiently designed enclosed box, this heat can build up. One other thing to consider is the insulation from the sun. If we have a lot of direct sunlight on the box, of course, that's going to heat it up as well. So cooling can be handled in a couple of different ways. It can be done passively just by setting a system up so that we're putting the electronics and the lead acid batteries in the container in a shaded area. We can use the PV array as the shade, or and then basically move the PV array out to a ground mount so that we get that full insulation. The other thing is that just active fan ventilation that's going to be required for lead acid batteries anyway is something that we consider putting in there to just move the air out, depending again on location. And finally, if we know that the thermal loading is going to be very, very high, both because of average ambient temperatures plus the electronics inside, going with an air conditioning unit and then a smart design around making sure that air conditioning unit is running at the most efficient times when the sun is shining, just as the sun begins to rise, or maybe even using a generator sometimes to make sure that system's properly loaded up and cooled appropriately before the start of the day. So a lot of different ways to make sure that we're managing the thermal load inside that inverter as well as possible. A lot of questions come up around storage and understanding where we can put storage into a system and exactly how we can best maintain that system. So for general application, of course, we need to understand that with lead acid batteries, either AGMs or flooded, there are some things that we have to take into consideration, especially understanding that when we're shipping it over great distances, be it a bumpy gravel road or inside of a ship for a shipping container or even for air, we have to make sure that we understand some of the limitations that come with doing that site survey and choosing the right technology. With AGMs, they can be vibration sensitive over the long haul because of the vibrations that can cause a separation on the plates. With lead acid batteries, depending on which way the plates are laid out, you can run into some lateral G sensitivity, especially over very, very bumpy roads. If the batteries are laid essentially on their sides, so the plates are parallel with the ground, that vibration can cause those plates to essentially bend, and we could end up with an internal short. With lithium, absolutely understand that there are some air restrictions attached to getting those out there. One way to get around both with the AGM and flooded lead acid batteries is using a slightly different style surface plates, which is using like the Discover tubular gels. where we actually have a tube so that we don't have these big flat plates, but instead we have individual tubes that are much more rigid inside. The other thing that we have to understand with storage options is that both AGM and flooded lead acid batteries like to be kept at a very particular temperature. We mentioned that in the last slide, around 25 degrees C. And when we're sizing a system out, I've done it before in other presentations and talked about it, but really you don't want to go below about 30% depth of discharge for either AGMs or flooded lead acid. That is kind of the Goldilocks, the sweet spot for those batteries, and making sure that we get the absolute number of cycles out of those and the best return on investment for them. Lithium, depending on the technology, of course, are very, very robust product, really dependent on the battery management system. Reach out to us if you're interested in lithium. We have partners that we've worked with for setting up communications. So the inverters really do need to be able to listen to and talk to that battery management system. We have partners that we're already working with for lithium. The upside of lithium, of course, is the energy density is very, very high when compared to flooded lead acid or AGMs. But as well, we can get more energy out of them based on the number of rated amp hours that are there. So a lot of weight savings and space savings can come with using lithium. Back to the AGMs and flooded, one last point, of course, is making sure that we have access. So when we're designing out a containerized solution, make sure that we have access to water them. Even an auto watering system is still going to require some testing of the system with specific gravity and things like that. They'll be part of the periodic maintenance with flooded batteries. And of course, I've seen it myself where thermal cycling of a battery has literally unscrewed the terminal bolts. So being able to make sure that we have access to the torque the terminals down is also very, very important for just maintaining this health of the system and making sure, again, best ROI, the most out of the system. So let's go ahead and spend a little bit of time talking about actually getting that containerized solution to the site. You know, one of the great benefits of actually doing a containerized solution is putting it into a truck that can easily be moved across country or even across pretty rough roads that we've already talked about with, you know, doing that site survey that also includes understanding how you're going to get it from, say, the ship to the truck and then the truck to the site kind of thing. But once on site, we have the ability to, because it's a container, very standard for containers to actually have forklift slots there. And so we can actually lift and move that container pretty much to any site. And then once it's on site, if it needs to be moved within that location, very, very easy to do. And then of course, once we get that site established, and let's say we need to move that container again, we can just load it back up onto the truck and move it out. One option, of course, when we talk about doing trailers and containerized solutions is to leave it on the trailer all the time and allow for a much more mobilized solution. This can include, and we have a case study on this, using a trailer that actually has a built-in axle on it. So compared to a drop-in structure, it's worth kind of, again, comparing those two ideas, is that with a drop-in structure, we lose that mobility, we lose that option to ever be able to put it into a different position. The infrastructure for actually building up that structure can be quite high. And then we have that additional wiring that needs to be permitted on site and still requires that skilled labor above and beyond. So definitely consider using a containerized solution just simply because it is its own structure. You're able to drop it in. The cost that appears to be high with a containerized solution can be very, very quickly overcome when you start adding in the labor costs and the skilled labor and just some of the risk that comes with an install, especially remote installs where bits and parts can go missing and you don't have that pre-tested, pre-configured solution ready to go. Let's go ahead and spend some time talking about the Conext XW Plus and why it's such a great option from Schneider Electric for putting into Containerized Solutions. Of course, the most important thing about the XW is just literally its versatility. We've talked about that throughout the presentation with its capacity to be able to bring in multiple storage. But with versatility, we're talking about the same footprint that will cover any voltage in the world. So the unit itself size doesn't change between IEC 230, 50, 60 hertz single phase, and then we can do the three-phase solution with three of the inverters to the single phase UL 120, 240, 50, 60 hertz, again, single phase 120, 240, or we can do 3 units in a stack for 3-phase 120, 208. That modularity for the system allows for that expansion. Very, very important thing to consider is we can start with a single inverter. As things grow, we can actually grow this system out to become a very large multi-cluster solution. If you work with Schneider Electric, we can do up to 102 kW on a system like that, and it really makes for a very powerful system, and that's using that external switch. If we were going to use an internal switch, then we would use a maximum of 36 kW size building block, but very rare would you have a situation where you have a single large inductive load that's, say, larger than 36 kVA. With that expansion into the future, each 3 stack of inverters can allow you to have its own battery management system, and thus it has its own energy storage. So you can grow with the system. The system can take 1,000 amp hours now, and you decide sometime in the future that you need more power and you need more storage. You're not going to have to separate everything out. As long as you have a common AC box, we can actually just wire in another unit of 3 inverters and actually bring in another 1,000 amp hours of batteries or even more. So definitely check with us if you're thinking about starting with 1,000 and then want to bring in 5,000 amp hours of storage. May have to take some things into account on how you do that. Okay, so with expansion into the future, if you build the system to already have 3 inverters installed and you want to be able to expand into the future, but budget's tight, you can actually wire everything up so that fairly unskilled labor can actually bring in and drop in 3 more inverters. As long as you've pre-wired everything, it's just a 2-man lift to get that inverter up onto the wall, and then a little bit of programming and away you go. With balance of systems, Schneider Electric does a great job with making sure that we have everything that you guys need to put that system up on the wall. And even in a containerized solution, the gutter system, our partners have talked about this when we were interviewing them for this presentation, how nice it is to have the balance of system from Schneider Electric with the gutter system, as well as just the AC combiner box there all ready to go. So it's really, really nice. Things that Schneider Electric offers, of course, is more than just the inverters. It's the charge controllers, which are going to be able to communicate. The MPPT80, which is kind of a favorite of mine, allows you to do those very large strings up to 550 volts DC, as well as, again, those AC and DC balance of systems. Help you get that generator started with the AGS, the battery monitoring system. You can have multiple batteries within that solution if you're using multiple inverters. We allow power meters. An example would be the IEM 3255 is a great power meter that is literally plug and play. Schneider Electric's Modbus is ready to listen for that power meter. And then, of course, with our ComBox and with Insight, we can control that system with a little help from an IT expert from anywhere in the world. Insight allows you and the customer to have access to that system, see what it's doing, see what's going on. Really, really nice way to keep track of things and keep the customer educated. The really smart design that we do with the side-by-side allows the inverters to be stacked next to each other because venting comes in from the bottom and air goes out the top. So don't set manuals on top of the inverters, please. But that side-by-side stacking allows you to maximize that use inside the container, as well as just keeps the running of conductors simplified because we can just run everything in that gutter system right underneath the inverters. The nice thing with the XW Plus is that it is very heat resistant. It's rated at 40 degrees C, so it could do its full output. And it can also has a great surge capacity, 12 kVA, very easily. So when you're designing for a system, you need to make sure that if you are designing for surges, that you take that into account and that you have enough cooling available. As well, with all of this stuff, of course, the XW can run up to 70 degrees Celsius with a D rate, of course, but will continue to run at some of those extreme temperatures. And, with the dual AC input, it allows us to have a connection to 2 different generators on site. If the site has that redundancy already there and they're looking to do that fuel offset, or it can connect to that grid. And we've talked about having that grid there. If it's a dirty grid, we can use that system to actually keep the power very, very clean using DC chargers. So very, very nice system that you can set up. You can sell to the grid. You can do load support with up to 6 inverters, so 2 sets for 3-phase. And then being able to change the parameters based on the AC input is also very, very nice to do. Schneider Electric's taken a great deal of effort to make sure that you guys have exactly what you need for the solution and for the XW Plus when designing out a system. We have a lot to offer there. If you go to our website, solar.schneider-electric.com, under Solutions, and then go to Off-Grid Solar and choose that XW Plus. Under the Downloads Technical Publications, you can see there that we offer drawings for CAD, as well as being able to offer single-phase and 3-phase wiring diagrams inside the manuals. We have some really nice white papers to help support multi-cluster solutions with that 3-phase. And as well, if you are looking to do some thermal loading and understanding exactly what it needs to be done for setting that system up to do higher temperatures, or you're going to have to do some active cooling, please reach out to us. We have that resource available. It just may not be on our website. So please check back often for what we offer there at Schneider Electric's website. You may be surprised with the things that we continuously update there for resources for you guys. But again, don't be shy. Please reach out to us if you do need something in particular for a resource to make you successful on a bid or an install. We're very, very happy to help. One of the most important resources that you can have once a system's installed and it's on site, of course, is making sure that that system is running well, that it's easy to program, and that you can receive alerts if something is amiss. And both through Conext Insight as well as the CommBox, you can see that system from anywhere in the world through Insight. Again, if you work with an IT specialist to help you set it up, say with using a VPN, you can use that CommBox to actually make control changes from anywhere in the world. On site, very, very easy to make changes, just simply connecting through a standard wireless setup along with a router, and you can see that system and connect to it. For that total system control setup, saving those settings so that you have kind of that stock settings ready to go. Data logging is going to allow you to see how that system's being used over time, and as well as within Insight and CommBox, you can see that data logging being done. And then as batteries change over time, of course, you have to change a couple things on the battery management system just to make sure that it's staying healthy. As batteries age, the capacity of those batteries gets smaller. So if you're making decisions based on state of charge, every once in a while you're going to have to get in there and change the capacity to the batteries to a smaller setting so that that state of charge number stays accurate. So something to consider when setting the system up, especially for remote sites, is making sure that you have a cellular or satellite communication so you can reach in and do those subtle changes that need to be done, or periodic changes that need to be done to keep that system at its peak performance and really make sure that you're treating those batteries well and getting the best return on investment out of those. For the next part, we're going to be talking about just some of the great case studies that some of our partners have done across the world and how they've brought in solutions to some very remote sites and kind of the whys and hows they've done it. I've alluded to them throughout the presentation that we have these. Very excited to talk about them because some of the things that they're doing are very special and very, very interesting. So just open your mind and think about how you can use a containerized solution now and into the future. For some of the applications, especially where you need that robust remote solution that's pre-tested and can be easily delivered to anywhere in the world. So let's go ahead and talk about some of those and see what it's capable of doing. So for our first case study, we're going to talk about Telonex. We have a couple different examples here within the slide. The first one there on the top left is talking about the solar-powered internet school. So it kind of acts as a mobile school both for daytime use and then as well as adult classes in the evening. Just below the container, you can see the system essentially, which is just in one end. So they have all this other room available inside the classroom for display, for the teacher, as well as laptops and lighting, and most importantly, air conditioning. And that's really what kind of gets the adults to come in the evening time. So the amount of solar that's on there is sort of supplementary. There is also a generator that's part of this solution. It keeps it as a hybrid solution. Up in the top right-hand corner, we have a really nice display by Telonex, just kind of highlighting how they can put everything into a container. Again, just like with the solar-powered school, just because of the location, the panels are located flat. Some of you may notice that there's some shading there on the school, but this was photos taken before it was deployed into the field. Down on the bottom right-hand side, kind of an extended idea of a containerized solution, but this is a pre-built solution that can be installed not by a professional, but just by an electrician. It's a pre-tested solution. If you could see just underneath the XW Plus, you would see that it has batteries. So this is something where it can be dropped in, final connections made, batteries done, and a very simple pre-tested solution that can be deployed inside of a home very, very easily. So Telonex is a great company based out of South Africa, and as well we'll be sharing some of their contact information. So if you are in Africa, Sub-Sahara, or even into the Middle East, please feel free to reach out to them. They're happy to give you quotes and work with you on what your solutions needed. So let's go ahead and move on to the next slide. The Solar Ship Hangar by Canadian Energy is a project prototype which acts as a central maintenance and logistics center for their big blimp, which is also electric powered for remote communities, basically a giant floating crane. With this solution here, we can see that we've got some Discovery gel batteries that are tubular type, so they're very resistant to the normal deployment risks that come with going over shaky roads and whatnot. For this system, they use the Cub solution, which is that 10-foot container. Within the solution, we have 6 of the XW Pluses for 36 kW worth of power, as well as a 40 kW array and a pretty healthy amount of storage at 160 kilowatt hours. With all this, there is a generator as well. So once we see in this photo that skeleton goes up and the structure gets completed, the Cub solution can actually go inside the logistics center as well. This logistics center charges and maintains the batteries on that electric blimp for deployment. And this solution can be deployed really anywhere in the world. So if you're interested, definitely look up Solar Ship and see what they're capable of doing, as well as Canadian Energy. Again, a great company that does a really nice job with containerized solutions. Another example by Canadian Energy with the Arctic Research Center. This is really a remote location deployment solution to reduce dependency on fuel for a remote community of about 1,500 people. So this is a 20-foot container. Again, we have a pair of XW Pluses for 12 kW of load power, as well as a modicum of solar, which is at 6 kW worth of solar. And really, again, this is to offset Fuel consumption, it's not meant to replace fuel consumption. The other nice thing we talked about a little bit earlier is using an alternative charging source. So in this case, because they're out near the water, they get some pretty good wind. So they've actually deployed 4 wind turbines up there as supplementary power throughout the evenings. The mill spray container solution is meant as a deployable generator and deployable solar solution with energy storage. So it's meant to have that 36 kW generator charge the batteries and allow the XWs to provide that variable load profile so we can reduce the amount of energy that's consumed. The PV compared to the size of the generator is fairly small, but this is really meant almost as a backup charging solutions so that we can keep the electronics going, monitoring for that solution. What's important to note about this 10-foot container is it can be delivered by Humvee to locations, and it's really meant to reduce that risk that comes with fuel deployment. The less times that you have to deploy trucks to refuel a site, the better off and the safer the soldiers are. So really that was the idea behind this solution. The other thing is to note that these batteries are actually very special batteries meant to work in very, very high temperatures. So the low specific gravity battery meant to be resistant to deployment in places like Afghanistan and other high temperature areas. So we can see here we have 3 XWs along with a pair of MPPT charge controllers, one for each of those arrays, along with power distribution. And of course the comm box, very important, just simply because that's what's going to allow them to communicate and control that system with their communications from anywhere in the world. With the Catalyst Energy telecom power solution, this is a solution where there was some concerns, if you will, about deploying solar panels in remote areas. So the decision was made not to use any solar. So this is really a diesel hybrid solution where we're just using batteries to charge up from that diesel source and then get that system turned off. Interestingly, because of the remote locations and fuel delivery costs, this actually has an ROI of about 3 years. So a great example of you don't have to have solar panels to actually get a system like this installed and being able to show return on investment. It's a secured box which keeps the system safe. You notice here between the left and the right that they have actually insulated the 2 walls. So the batteries are insulated away from that heat developing source, which is the inverters. So a great way of planning out the system to keep the batteries as cool as possible and allow the inverters to run at their maximum efficiency as well. The Solar Rover Power Trailer is a solution with just a single inverter and a pair of MPPT 60 charge controllers, one for each of the arrays there so that you can have them at different angles and have that MPPT track correctly. Purpose behind this is to be able to bring remote lighting or a PA system to events, be it soccer games or to a music event, be able to deploy this very, very easily in this trailered solution. So again, a containerized solution expands beyond just being inside of that kind of, we're used to seeing container for shipping, but we can put it all inside of a box with an axle on it and be able to move this system where it's needed, pre-charged, and then be able to use it with the supplementary power coming from the array. And then once the event's done, be able to just simply bring it back to home base and connect it to an AC source and begin charging again. For the WA Solar Wraps project based out of Australia, this is a mining operation where they needed to have a mobile solution where they could move it when they needed to. That bottom center photo shows some of the old infrastructure, which was just a simple generator. Of course, we want to be able to offset our fuel, so an array was deployed along with a mobile solution. The nice thing with this solution, if you notice up in the top left photo there, you can see, as well as in the bottom left photo, little footers there, and that's how they deployed it to the site with a easy forklift movement there, and then redeploying the concrete footers allows that system to be moved if necessary, when necessary. So this is again to support a mining operation, and again also to offset the total fuel consumption for an install. For the total system, of course, this is a 20-foot container with 3 of the XW inverters, along with about 20 kW worth of solar, which is used with the 4 MPPT 80 600 volt charge controllers. So nice solution of showing how easily something can be placed in a semi-permanent location, but the availability to pick it up and move it is always remaining with this style of solution, because it's just, again, those concrete footers. We spent time talking about containerized solutions, shown some of the case studies, and we also have a couple of partners in the business who we know are going to be great partners to you if you decide that you want to install a system. There are others out there, so please feel free to reach out to us if for some reason that these two partners aren't either in the right part of the world. We definitely have more contacts for other partners who can do these styles of containerized solutions. So let's talk a little bit about them and what they have to offer. Telonex is based out of South Africa, and that's really their main deployment area. They are able to build just about anything that you need inside of that modular solution. The really nice thing is that they've done it in some very, very harsh environments and really understand exactly what's needed. This partner, along with Canadian Energy, who's in the next slide, both do a fantastic job because they have partnered with container manufacturers to build exactly the right size and the right product that's needed for deployment. So they're not just using a standard container, they're using very specialized containers built for them. And again, the best part about this is that they can go from concept to project to deployment in a very, very short period of time. So please feel free to reach out to them, and they can help you deploy a solution in Africa or even in the Middle East. For Canadian Energy Solutions, their main focus is the Americas as well as Latin America, so feel free to reach out. They really do a nice job if you just need some equipment. They also stock the Schneider electric product line. They do design and build the Cub solution that we've talked about in previous presentations, as well as can do custom solutions really to anywhere in the world with that focus within Canada, US, as well as Central America and Latin America. I want to thank everybody for attending the webinar. Please feel free to reach out to me if you have any technical questions. Make sure that we get the answers to you or introduce a partner to you that may be in your region. If you're having trouble reaching out to Telonex or to Canadian Energy, please feel free to reach out to me. For Colin, if you have a project you're ready to go and just need contact with a distributor, please feel free to reach out to Colin Carroll. He can definitely get you connected in that area. So thank you again, and I look forward to seeing you at the next webinar.